It's my pleasure to extend a cheerful welcome to you all to this free online summer course on IoT based application. Welcome the challenges, look for the opportunities in every situation to learn and grow in wisdom. I now extend a warm welcome to our resource person for this evening, Mr. Gokul Yam, on behalf of our respected college chairman Sri D. Duraiswamy, Vice Chairman Sri D. Parandaman, Secretary Sri D. Dasrathan, Joint Secretary Sri S. Gopinath, Correspondent Sri S. Amarnath, Director Sri D. Sabrinath, our beloved Principal Dr. S. Ramachandran, Head of all UG and PG departments, professors and faculty members and students of our institution. Thank you, Mr. Gokul, for joining with us today.
Yeah, thank you, Niveda. Shall I start the session? Is my voice is audible?
Yeah, it's audible.
So can I start the session or I don't wait, sir?
You can start, sir.
Good evening, everyone. I'm Gokul, and I'm living in Chennai, and I'm doing engineering specialized in electrical and electronic department. And I would like to present on a project IoT based smart home, and I did this under the guidance of Dr. G. Rohini, head of the department electrical and electronic engineering. Generally, everybody knows about the term IoT. Nowadays, these kind of terms are more familiar, like IoT, machine learning, ML, AI, like this and that. In which we are going to see about the IoT based applications, and in which IoT stands for Internet of Things. And generally, Internet of Things conceptualize the idea of remotely connecting and monitoring real world objects through Internet. But nowadays, these are more common to all, and this have this plays a vital role in the change of industries into industries 4.0, and we are going to see this in IoT application for the smart home, and this mismatched abstract. And here, Internet of Things conceptualize the idea of remotely connecting and monitoring real world objects through Internet. When coming to the industry, there are no much constraints like the implemented the proposed system should be very cheaper, or it should be in the compact size, not that much and all. But when it comes to the home, this concept can be aptly incorporated to make it smarter and safer. And more important thing is we need to make it is cheaper, so that only everyone can buy this system and use the system for the own use. Because as like a smartphone, if the smartphone is now manufactured for, or is sell for 50K, 50,000, or above 1 lakh, is everyone can able to buy that. But why everyone can able to easily buy that? Because we can get the all the features within the certain money, that is certain cost. That's why we can able to buy that. Likewise, if the home automation system also comes under this kind of low cost, then everyone can buy that and use that for their to make their home smarter. And in our IoT project, it focuses on smart control and monitoring system through which we can control AC loads, watering the plants automatically, and also can get the alert for water level in the tanks, which raises an alarm optionally. That is during filling stage and empty stage and in the full stage also. That is filling in the sense above 90 percentages. And besides the same can also be utilized for automatic window actuator control. That is closing, opening and closing the window, which reduces the room warmness. That is for ventilation purpose. This will be mostly incorporated while using air conditioner. This will reduce the cost of the electricity bill. Next, coming to the existing system. Here, the existing system were controllable LED by using smart Androids and control and monitoring of socket systems. Smart home system using Arduino. That is, in our system, we are using different microcontroller. I will discuss it later. But in this system, here it is used Arduino. And next, smart room temperature control by means of IoT system and smart home system based on GSM. And the GSM in the slide denotes that global service system for mobile communication. And this one is the first one, controllable LED using smart Android. Here, by using this Android application, that is a smart Android phone, we can control all these loads like AC LED lights. By using this, we can control the AC lights, and we can control the fan also. But in this system, we are controlling the LED. These are the existing system. After completing the existing system, I will tell about my system. That is my project. By using this mobile application, we can only control this um, smart home. That's the main point. We can't get the real time feedback of what it happens like that. And it's coming to the control and monitoring of socket systems. That is the regular home sockets like 5 amps, like 5 amps or 10 amps like that. And this one is the completed product that was developed. And here it is controlled by mobile phone remote control or Alexa voice control, like giving command to the Alexa, and by means of that also we can control this socket, whether it should be in turned on or turned off like that. And we can see the power rating also in the real time. How much power is used in between which time and which time, how much power is used for a certain hour or for a certain day or for a certain month in this socket alone. And this can be controlled by either by one or group control is also available in that. And this one is the high temperature flame retardant. That is the material which is made, that insulating material is very flame retardant. That is, it can able to withstand high temperature, so that it will be more affordable for usage. And timing control is also possible by using this. That by using this we can control the timing of the load, certain loads, like this system or this appliance should work for this much hour only, like that. We can control, we can set in program in this by using this setting control, timing control, and we can set here. Next, coming to the smart home system using Arduino. Actually, in our project, we are using different microcontroller, but here in this system, Arduino is used. And here you can see the Bluetooth module. By using this Bluetooth module, we are connecting this whole home automation system to this mobile application. You can clearly see that Bluetooth controller in that. And these are all the relays for turning on and turning off the certain loads which we want to operate. And as we know already, this microcontroller, Arduino microcontroller is based on the processor of Atmega 325. And here the Bluetooth model, ESP 12E Bluetooth model is used separately, but in our system it will be combined with that. I will tell it later. These are all the solid electromechanical relays only. And next, coming to the smart room temperature control for IoT systems. And in this we can control the room temperature, that is by like turning in this system we are turning on the fan by using the room temperature. Like it may be presetted for about threshold. Here you can see the threshold level is 32. If the temperature is above 32 degree, then the fan is automatically turned on, like that only it will work. We are also using the similar principle in our project, but in a different way, in an innovative way, which will reduce more electricity bill cost. Here by using you can monitor the temperature, real time temperature and humidity of the room through this temperature and humidity gauge. And indicator is also used uh, for knowing whether the proposed the implemented system, that is turned on used system, is turned on or turned off, or in that is in on condition or off condition, like that. This will be more useful. Next, coming to the smart home system based on GSM model. As we know already, GSM stands for Global System for Mobile Application. By using this, we can connect this processing unit to this mobile without with or without internet, like that. That is, we are using a sim management tool for the connecting this mobile to this controller, not through Bluetooth or Wi-Fi, like that. Next, coming to our proposed system. And our IoT project focuses on controlling AC loads, as I said already. That is AC load in the sense like fan load, light loads, etc. We are controlling it automatically, and we are getting the real-time feedback of what we are controlling. Then coming to the automatic plant watering system, we are watering the plant which we plant in our house or home, and we are getting the feedback that the plant is the moisture level in the soil, and we are utilizing that sensor data, and we are controlling the pump to water the plant, that system actually. And next is water level indication. By using this water level indication, we are detecting the percentage of water in the tank, and how much is that during the normal state. And while filling in the filling state, it will be keep on increase, or in during the usage state, it will be keep on reducing. If the temperature is reduced below the certain level also, the user will able to get the notification. And if the temperature is above the 90 percentage also, the user will get the notification. And basically the same can also be used for window actuator control, that is automatic window actuator control. That's our small innovation. And we are incorporating the temperature sensor for making this into a system. And by using this, we can control the window actuator, that is open or close the window according to the room temperature as we program. And all these operations are carried out by Node MCU, which is integrated with extensor processor. As I told already, in Arduino, we are using Atmega 325 processor, but here we are using extensor processor. Like Arduino, here we are using in this system, we are using Node MCU. It's Node MCU. It's full form is Node Microcontroller Unit, and which is integrated with extensor processor and ESP8266 Wi-Fi module. In the As I told in the previous slide, that is a separate Wi-Fi module is used, that is ESP12E Wi-Fi module is used separately. But in this system, there is inbuilt ESP8266 Wi-Fi module. It's a benefit of this Node MCU in the low cost. So that only I'm using this Node MCU. Then where the control and monitoring process is done through Blink application. Yeah, the whole system is controlled by Node MCU, but we are commanding this system through a Blink application in our mobile or laptop or system web dashboard, like that. It's a Blink IoT platform, so we can control this whole home automation setup and monitor this whole home automation setup from anywhere in the world, since it is then a cloud-based system. Next, the whole system is under closed loop. Closed loop in the sense we are getting the real time feedback data of the system which we are using. That is, through the sensors, we are getting the real time feedback. Then we are getting that feedback into the mobile itself. So it's a closed loop one. So it's a we can, by using the system, we can increase our gain, that is efficiency, which is a must needed one for smart home control, so that only the user can able to view the real time data of the sensors and everything, and whether the home state of the gas, water, like that. Next, coming to the our proposed system, first, as I said earlier, I'm using AC load control. I will tell one by one. And this one is the automatic AC load control. We are controlling the AC load automatically only. Then why we are tend to use that IoT here? Normal automatic AC load control uses a microcontroller which controls the lighting or fan loads according to the human presence, but we can't able to get the real time feedback of whether the load is turned on or turned off, like that. We can't able to control this in mobile application, but here in our system we can get the real time feedback of what we are controlling by means of this uh, IoT system. And here you can see the PAS sensor, but in our project I'm using ultrasonic sensor which tends to detect the human presence, and after that it will trigger the node MCU microcontroller, and it will process the data, and we can control the we can control the load accordingly, what we are as we programmed or as we planned. Here in this we are controlling we are controlling the load according to the range of 1 not 5 degree, and in the distance of 8 meter in horizontal direction. And likewise in our project I'm using ultrasonic sensor. It will cover up to 110 degree, and then it is programmed in such a way that it can detect the human presence up to 1 meter, but we can control up to 4 meter. But I'm using programmed in a way so that it will operate only within the 1 meter circle, so that it will be easy for the process for showing a demonstration or like. And next, coming to the automatic plant working system, as the olden yes, we are using moisture sensor here, and we are by using the moisture sensor we are sensing the data of the soil, whether the moisture content of the soil, whether the soil is in dry state or in wet state or in semi-solid state, like that. We are getting the real-time data of the soil, and we are giving that as an input to our microcontroller. And then by means of this controller, if the temperature sorry, the moisture level is above 80 degree, that is above 80 percentage, then the corresponding pump will be turned on to supply water to this plant, such that if the plant get watered or water, then we can use this system accordingly. We can use this implement this system for roof gardening and like that. It's for home application. For agriculture purposes also it is widely used, but for home application it will be used for small plants, plants and roof for roof gardening maybe, and we can use for that according to our wish. And next, coming to the water level indicator. Nowadays these type of indicators are available mostly, and why this system is used, because the existing system is there and its performance is very good, but its cost is high as of the people. The cost is high, too much higher the cost is very too much to buy the system and implement in our home, like that. But our project eliminates all these constraints, and came up with a new solution for developing these things in cost effective manner, that is cheaper, for which will be used for the people, which will be more useful for the people, that is an average middle class people or upper middle class, like that. And here also ESP8266 node, that is node MCU, is used. By using this, the we are detecting the water level of the tank. That is, we are placing the sensor at the top of the tank such that it will detect the water level, and it will get the we can get the real time feedback of what we are doing in the this dashboard. And by using this, we can measure whether the tank is in full stage, or the tank is in 3/4 stage, or the tank was in full stage, like that. And we even get the alarm optionally, like if the percentage of tank is above 90 percentage, then we will it will this our system will raise an alarm optionally, such that it will be we can use this alarm, and we can control the pump for storing the water in the tank automatically. Next, coming to the automatic window actuator control. For this, we are using 9-volt window actuator for opening and closing the window accordingly, and we are using an limit switches for controlling the actuator within the range. That is, it should not go beyond the certain preset value, preset distance, or preset operating quantity. And for this system, we are using incorporating the temperature sensor. By the temperature sensor, we are detecting the room temperature, and by using that temperature, that is predefined one, we are controlling the window actuator, and parallelly a ceiling fan that is installed in that room itself. And here in our system, I shown this by means of motor, and I have shown that ceiling fan by means of BLDC motor. Next, coming to the block diagram of our system. Here, as I told already, as like Arduino controller, we are using Node MCU for our process. And here I'm using four sensors, that is an ultrasonic sensor, and moisture sensor, proximity sensor, and temperature sensor, as you can see in the left hand side. And in the right hand side, you can able to see the loads, like bulb or fan loads, and water pump, that is for pouring water for the plant. And next, the buzzer for raising an alarm while storing water in the tank. And motor actuator or fan, that is for that is for AC load controls, and that is for automatic window actuation control system. We are operating the window actuator and a fan parallelly, so that by using this, we can control and the whole system is controlled and monitored by blink app. It's a two-way, actually. We can control this node MCU, and the node MCU sends the data for us through this blink platform. So I've shown like that. And by using this ultrasonic sensor, we are detecting the human presence and giving this sensor data to this node MCU. And this node MCU will process the signal which is got, and it will it will turn on the corresponding fans or light by means of an electromechanical relay that is used. And next, by means of the moisture sensor, we are detecting the soil moisture, as I told already, and we are giving that as an input to this node MCU. That is, we are utilizing analog pin of this moisture sensor. We are giving that as an input to this node MCU, and we are controlling the corresponding water pump to pump water for the soil. Next, proximity sensor, and there are many types of proximity sensor, and in that we are using there are many type of proximity sensor, like ultrasonic proximity sensor, IR proximity sensor. These are all the proximity sensors types. And here we are using ultrasonic sensor alone. And we are giving the similarly, we are as like my ultrasonic sensor one, and moisture sensor, we are giving data, this sensor's data also as an input to this node microcontroller, and we are processing it, and we are turning on the buzzer correspondingly. We are operating the buzzer accordingly. Next, temperature sensor. Here we are using DHT11 sensor, which detects the room temperature, and this input is given as an input to this node MCU, and this node MCU will process accordingly, and after that, corresponding motor and actuator and fan is controlled. This whole system is operated under closed loop, and we are getting the real-time feedback for the system through this Blink application, that is Blink IoT platform. And next, this is our node MCU. Here you can see that this one is the ESP8266 sorry, ESP8266 module, and here you can able to see uh, VIN, that is input for this microcontroller unit, and a ground terminal. Through this we can supply power for this node microcontroller, and it's operated from it works from 5 to 12 volt, 5 to 15 volt, and we can power this node MCU by using this micro USB pin also, and this one is the flash and reset pins for this microcontroller unit. Through this we can program, uh, we can reset and can store the program, that is erase the program accordingly. Here you can see these there are 13 GPIO pins according similarly. These 13 GPIO pins, that is general purpose input and output pins. We can control these pins as both input for input and output side. But one disadvantages of this Node MCU is it has only one analog pin. That's one small disadvantages. But the updated version or upgraded version has two or three analog pin extra. Why we are using analog pin means this will be more useful for while using sensors. Most of the sensors like gas sensor or moisture sensor and some other sensors may utilize able to utilize the analog pin. Then only it can able to detect the sensor value. By using that only we can. But in our project we are using only moisture sensor, and by using this this one analog pin itself enough for power system. So I am using this node MCU, that is ESP8266 node MCU. And another thing is, here you can able to see that 3.3 volt ground, like here also you can able to see, and there are three ports for this. And by using this three points we can power up the sensors or any other displays, but we can't use this 3.3 volt for powering up of a display, but we can use this for some sensors, some like a temperature sensor. We can use this for our for powering up the sensor, so it will be used as like in Arduino microcontroller. We are getting the facility of 5 volt supply like that, but in our system we are getting we can able to get only 3.3 volt power supply. It's also one of the disadvantages. If the system consists of a 5 volt supply, that is able to, if the system able to provide a 5 volt supply, then it for some more sensors like moisture sensors or ultrasonic sensor need 5 voltage. So if we able to get a 5 voltage directly from this node MCU, node MCU, then it will be better. It will be a better option. But this facility is not there in this node MCU, but it's not a big problem, but it's some disadvantages. And this one is the regulator which converts this 5 volt input. By using this micro USB, both micro USB and V in ground supply, either this or that, we are giving that input. But this should be converted into 3.3 volt for some certain sensors or some other things. But by using this regulator only, we are converting that 5 volt or 8 volt supply into corresponding 3.3 volt supply. Next, coming to the circuit diagram of the proposed system. Here you can see the node MCU here, and this one is the ultrasonic sensor. We are here, as I told already, we are using two ultrasonic sensors, and these are the transistors. That is NPN type transistor, and it is BC547 number. And these are the electromechanical relays. I'm using four electromechanical relays that we can see in the sorry, in the project image also. And Here we are using a 5 volt regulator for converting that 9 volt into 5 volt for the sensors and node MCUs. As I told already, I'm using 9 volt supply for this whole system project, and I'm converting this 9 volt power supply into 5 volt by means of this IC7805 regulator, and giving that as an sorry giving that as an input to this ultrasonic sensor and ultrasonic sensor one and node MCU accordingly, and then I'm powering that moisture sensor and temperature sensor also by using this. We can for temperature sensor we can use either 3.3 volt to 5 volt. So giving 5 volt supply to this temperature sensor is not a big issue. Then as I told already, I'm using only moisture sensor, so that I'm using that analog pin of the ESP8266, that is node MCU, as an control pin for this moisture sensor. We are getting input from the moisture electrode, and we are giving that as an input to this node MCU analog pin. Uh, Here we are using three motors. That is one motor for controlling a normal AC, like AC load, and another motor is for controlling that is AC window actuation control process. In that we are using both motor and actuator separately. And by means of this moisture sensor, we are turning on this pump motor accordingly. And next is a common load control. We are by using this ultrasonic sensor one. We are getting input to this node MCU, and we are controlling the AC loads accordingly. Sorry, I missed one. This one is the buzzer which raises an alarm. I connected to this buzzer to the D1 pin of the node MCU. And this one is the whole hardware setup of my project. Here you can able to see more things like this one is the SMPS for powering up this whole home automation system. That is, I'm providing 9 volt supply to this home automation setup. And this one is the power supply side, that is a regulator setup. As I shown in the previous circuit diagram, this one is the regulator for sorry this one is the regulator for converting 9 volt to 5 volt supply for powering up this sensors and ESP, that is node MCU, like that and all. For normal AC load control, I'm utilizing this a 12 volt LED, that is 50-watt LED, and this one is the moisture sensor, as you know. This one is the temperature sensor, and these two are the ultrasonic sensors. Here you can see the four relays, electromechanical relays. This one is the pump setup for watering the plant. And instead of using the actuator, I'm using this motor to load. It's quite understood, like for actuator also we are providing we are using motor actuators only, but instead of that, we are for showing demonstration purpose, I'm using this motor. It's understood. Next, for normal AC load control, like fan control, I'm using this BLDC fan. As I told already, we will get the real-time notification of what we are getting from the sensors. We are getting the data from the sensors, and we are using that sensor for our verification. That is whether the proposed system is turned on or turned off, like that. I will show the demonstration of don't worry. And this one is the blink notification which we are getting in the mobile. Actually, this one I took recently, and in the first one, we can clearly see the water level. That is, water level indication is shown in the blink notification. It will come like a normal message uh, with a normal message tone, so it will be somewhat useful. Like whether the tank is turned full or it is in empty state. All notification we will get in this link notification. And next one is temperature alert notification. As I told already, for normal actuator control, we are using this temperature alert setting. That is, if the temperature is above 30 degree, we will get the notification in this blink notification, like the temperature is above 30 degree and the proposed system is working. That is, this is actuator is on, so that the window is in open state. We can identify by using that. As you can see, the project title here, IoT based smart home. And we can even able to get the Gmail notifications also. It's an optional one. It's not compulsory to get the Gmail notification. It's an optional one. I'll show it later. This one is the continue. Is my voice is audible? Hello.
Yeah, it's audible.
Yeah, sorry for the inconvenience. Yes, coming to the web dashboard, that is what we are getting in the mobile through this mobile application. And here we are using Blink application as I told already. And this one is AC load indicator setup. That is during the off state, this will be in white color, and when the load is on, it will turn on to the green color, such that we are using ultrasonic sensor only. We are operating this. By using this, we can identify whether the load is we are using the load or not, whether the when we are out of the home, whether the load is used or not, whether the load is turned on or turned off in with on state or off state, like that. And this one is the water level gauge. By using this gauge, we can identify the percentage of the water level in the tank. If the percentage is T, like T, then the tank is about to have 50 percentage of water in the tank. Like the percentage is in full in the tank is if the percentage is 100, then the tank might have been full in the full state. Then by using this moisture level sensor, we are getting the moisture level of the soil by means of a moisture sensor, and we are getting the real time feedback of the moisture level in this moisture level percentage dashboard, and in moisture level gauge also similarly. And here you can see the pump state, that is the pump which is watering the plant. We can see the pump state, like whether it is turned on or turned off, like that. We can see the green red color indication in our dashboard. Next, coming to the and this white in this blue color dashboard will display that the pump is turned on or turned off. It will be somewhat useful. Next, coming to the temperature and humidity gauge that we are getting from the temperature, that is DHT11 sensors, and we are getting the real time feedback of the system through this display also. Like as I told already, this will show the green color when the load is turned on, and this will show the red color when the pump is turned on. Likewise, when the actuator is turned on, this will be showing as in the blue color. But if the actuator is non the is not in the off is in the off state, then it will might have show like in white color. By using this, we can identify whether the window is in open state or in closed state, like that and all. Actually, I have seen one question in the. Okay. Next, coming to the Gmail notification. By using this Gmail notification, we can see we can get the data from the sensors, and we are getting the data like sensors data like water level alert and temperature alert, like that, as like in Blink notification. And next, these are my reference to the towards my project and design and implementation of home automation system, value-based home automation system, or today's market, and smart home system using Android applications and PC remote control of appliances by using the telephone lines, etc. And first, I will show the working demonstration. After that, I will tell about the sensors and all what sensors which can be used to the home. Since we are using the closed loop system, and for implementing in IoT system, sensors plays a vital role. For that purpose only, we are using different types of sensors. This is my project video. This one is the regulatory unit which I used to control 9-volt supply into 5-volt supply. Here you can able to see that I kept buzzer under this node microcontroller. This one is the node MCU unit which I'm using, and this one is the buzzer which intimates it raises an alarm actually about the tank percentage in the, that is water level in the tank. And this one is the relay module for operating the load, that is for turning on turning off purpose. I'm using electromechanical relay. And this one is the SMPS that I'm using for converting providing power supply to this home automation setup, that is for providing 9-volt supply. This one is the ultrasonic sensor. And this one is the temperature sensor. This one is the temperature sensor. And this one is the moisture sensor for detecting moisture. And this one is the normal 9-volt geared motor, and it is brushed gear motor. And this one is the BLDC motor, that as like we are using ceiling fans. Instead of using that ceiling fan load, I'm using this DC load. And next I will show another video, that is operating video. Since now I shown only the a video of the project, but I will show the working demo now. Here you can see that this motor is used instead of the actuator, and this BLDC fan is used instead of the ceiling fan load. And this is in the previous state itself, in the beginning state itself, this will be in on state, because the temperature is above 30 degree is measured by means of this temperature sensor, so that the corresponding loads like actuators and AC fan loads were operated from the beginning itself. Sometimes the load is getting turned off. This is because I'm using air condition. I used air condition to provide cooling temperature, such that if the temperature is below 30 degree, the corresponding loads will be turned off, and it's keep on the temperatures keep on varying, so that only the load is turned on and turned off sometimes. And next, instead of the using pot setup, that is plant setup, I'm using this water for the moisture level. And by using this, we can detect the moisture of the water. Since the water, when the moisture sensor is dipped into the water, the corresponding pump, that is pump load, is turned off. When we are taking this moisture sensor out, then the pump will get on state, and the corresponding plant will be water accordingly. Now you can see that, able to see that the pump is turned on, vibrating. Actually, we have to mount this ultrasonic sensor at the top, such that it will detect the water. But for demonstration purpose, I kept this ultrasonic sensor in downward, in the down itself. And we are keeping by adjusting the hand itself, we can get the feedback of the like what we are seeing, we're able to see in the tank. By using the hand itself, we can able to test the ultrasonic sensor. Actually, will get the real time feedback of all these things in our Blink IoT app. But while I'm only using only one mobile to capture this image, so in that mobile only I'm using that Blink IoT app, so I can't able to focus both the things simultaneously. But I will show this one later. Here you can able to get the beep sound when the water level is about 90 degree. That is when the hand is nearer to this ultrasonic sensor. This is normal AC load control by means of an ultrasonic sensor. Actually, I got one question in the YouTube chat box. That is, I'll say the reason why I'm using ultrasonic sensor. That is, why using ultrasonic sensor instead of that we can use moisture sensor. The question is asked like that. Actually, we can use moisture. We have to use moisture sensor, PAR motion sensor for this project. But while using that, while using that PAR sensor. Actually, I tested with that only. Firstly, I tested with that PAR sensor only. While using that PAR sensor, often I am getting the fault signals from the sensor. And for getting a good operation system, we need to use high quality PAR sensor, such that we can avoid that fault condition. But I need to mm, built the system within a predefined cost. So I've used ultrasonic sensor itself. But for a high quality usage, we can use PIR sensor with high pricings or high ratings. Here you can see when the hand is kept near the ultrasonic sensor, we are getting the AC, sorry, DC load turned on. Now I will show the web dashboard live performance. Just just a short video. Here you can see the indicator is showing green color. That means the load is getting turned on. When there is no human presence, the load will get that is the green color indicator will be turned off accordingly. Next, the water level indication. Can see the water level like 80%, 88%, like that. Actually, I'm moving the hands at the ultrasonic sensors. Here you can see the moisture sensor data. While taking the moisture sensor outward, the pump is turned on and the moisture level is dried. So we can see that by using this red color indication, we can see whether the pump is turned on or turned off like that. And in the blue color LED board, we can be able to see the pump is in on state or off state like that. Now it is in off state. Next, these are the room temperature and humidity gauge, as I told earlier. Yeah, that's it. Next, I'll carry on with these slides and a few slides. This one is the ultrasonic sensor which I'm using. It consists of trigger and echo pin. By using the echo pin, trigger pin, we are triggering the ultrasonic sensor. And by means of the echo pin, we are receiving the signal. This ultrasonic sensor works on the principle of the sound travel distance. That is, one sensor will transmit the sound, and which is not audible by humans, and one sensor will receive the receiver sensor will have the microphone setup such that it will receive the data and will be given the there as an input to the node MCU. Next, this one is the moisture sensor. It will detect the moisture level of the tank. Here we are can able to see on a 4 pin, that is VCC ground, and analog pin and digital pin. By using this, we are detecting the moisture level of the tank. Sorry, moisture level of the soil. And this one is the temperature sensor. Actually, when the temperature, here it consists of two metals. When the temperature varies, the corresponding resistance associated with this will be vary. So it will produce voltage accordingly, such that we can able to detect that this according to the voltage level, we can detect this much temperature. The temperature is in this much level or that much, like that, like temperature 30 degree, 35 degree, like that. And this one is the PIR sensor. By using this, we can detect the motion of the humans, and humans as told in the chat box, like even it will present the animals insect like that also. It will work on the principle that the heat which is that is the infrared rays which we emit, that is the humans or animals which emit, it will detect that, and it will produce the voltage accordingly. And this one is iOS sensor. Mostly it will used for edge avoider robot, like that and all. By using this also, we can use the smart AC load control. And this one is the okay. As the time is up, I will fast forward. This one is the gas sensor for detecting gas level. Even by using this sensor, we can detect the smoke level also. For utilizing this gas sensor, we need an analog pin so that only I didn't implemented this in my Node MCU controller. But this will be more useful for safety purpose. And this one is the flame sensor. It's the flame of in the house. Um, Mostly it will be used for industrial purpose, but in our house also we can use for inside the kitchen, like whether if the fire is found, the corresponding door should it should corresponding system should be operated to stop that fire, like that, like water should be poured over that system, so, to stop the fire, like that. This is the LDR sensor, that is light dependent resistor sensor, which detect the light, whether if the sensor is shown before the light, then the sensor will send the data accordingly, then the corresponding load will be turned on or turned off. Mostly this will be used for street light turn on control. That is, when the light is not present, the light will be set. Whether it's only when whether in the night time it will be more useful. And this one is the current sensor for measurement the current. uh, they should be connected in series to make any use. Next, this one is the voltage sensor. It should be connected in parallel across the load, so that we can get the voltage. It will work on regarding to the voltage. That is, we can't able to measure the voltage by means of this current sensor and voltage sensor, but by using this sensors, we can as predefined one. If the by using I'll say from the current sensor, current through this current through a particular line is above predefined value. Like it uh, should not pass current over 5 amps rating. It should not operate above 5 amps rating. Then the equipment or appliance may fail. In that case, we can use this current sensor, and if the current level is above the 5 amps, then I said for the example, if the current amps is above 5 amps, then the corresponding system will be operated. By using this, the voltage sensor also same principle, but we need to connect it in the parallel. Next, at last, I need to conclude. And survey of different home automation systems shows that there are various kind of technologies used in implement the system or this type of system, but which reveals some merits, some demerits of the system. Nowadays, the systems were available, but more costlier. But in our project, we minimize that cost, and we it will be available for all the people. It is more of this is more affordable price. Finally, I will reveal my project cost. And if we are giving if there is the whole project cost is around 6,000, including the manufacturing cost also, such that so that it will be easily affordable, and it can be easily implemented in the home. And actually, the window actuator setup only increases the cost. Else we can provide this whole system within the 3,000 range itself. But for window actuator control, we are spending more money for that. But by using that window actuator control, we can reduce the electricity bill, so that we can balance that, and we can tally that. And that window actuator control can be used for ventilation purpose also. That so spending money for that much is more affordable compared to other IoT systems. And compared to other IT systems, due to its performance and simplicity, low cost and reliability, home automation system is making its position in global market. Yeah, nowadays this system is very viral, and the day is not so far that when everyone homes will come with the smart home. As of like now, everyone we are using smartphones. Everyone, that is at least one in a home. At least one of them is having a smartphone. Like that, the smart home system also will be implemented in everyone's home. And thanks for listening. Thank you. I got some suggestions from Jagan projects. Okay, I'll improve. Thank you. I'll improve. Yes, I need to improve my panel wiring. And thanks for the management for providing this opportunity, and thanks for the thanks to the HOD, Dr. G. Rohini, HOD of the TPD department, and thanks for Meghala ma'am for insisting me to do this presentation. Thanks a lot. Thank you.
I would maintain that thanks are the highest form of thought and that gratitude is happiness doubled by wonder. Gilbert K. Chesterton. Thank you, Mr. Gokul, for your outstanding discussion. We have now reached the end of this session, and this is the time to extend our gratitude for the successful completion of today's event, IoT based applications. Gratitude is like a magnet. The more grateful you are, the more you will receive. I deem it my privilege in proposing the vote of thanks. At the outset, I would like to extend my sincere gratitude to the management for providing an opportunity and extending full support to organize such an event. I would like to thank our principal sir, Dr. S. Ramachandran, for being a source of motivation and guiding us to conduct such events. I would like to thank our most eminent speaker, Mr. Gokul, for spending his time with us and enlightening the